Hello guys, welcome to Matematika class with me, Mem Ruth. So today, in this video, we will learn about trigonometric formula, and this is the first part. So what we will learn today? Let's see here. So the first one, we will learn about trigonometric formula for compound angle for cosine. And then, we also will find the formula for sine and the formula for tangent. So let's get started. Before you begin this video, if you feel that you still not remember the formula of trigonometry from 10th grade, so you better to see the other video about review of formula. The content will be like this: any special angle, and also the relation between angles in all of the quadrant. So you can see the video later if you think you need it. Now, we will start our lesson today with this kind of thinking. So first, you know that cos 60 equal half, right? But now, what is cos 15? If we need to calculate cos 15 without calculator, of course, how to calculate it? So, if we think about, we have 60 and 45 as special angle, and 15 is 60 subtracted by 45. So, is cos 60 minus 45 equals cos 60 minus cos 45? We can think that just put the cos in, right? But you can try and compare later using calculator, and this is not correct. So how to calculate it? That's why we need to calculate the formula so we know later how to calculate cos 15. We start with this unit circle. We will use this unit circle to find the relation between alpha and beta. So you can see that this unit circle has radius of 1. And this point, we suppose this point as x, y. With the angle to the x-axis is alpha degree. So we'll try to take this triangle out and find out the relation between x, y, and alpha. You still remember the formula, right? I usually use SOHCAHTOA, or maybe you remember it in Demi Sami Desa. So x, alpha, and 1 is connected with the formula of cos. Cos alpha is x over 1, sum mi, samping per miring. So you have x equal cos alpha. At y value, you can calculate it using sine alpha, which is y over 1. So y equal sine alpha. Then we can change this become cos alpha sine alpha, right? For this point, using the same way, you can make it become cos beta sine beta. So now, since we already have these 2 points, to relate that 2 points, we have a distance d here. So we can calculate d. How to calculate d? Do you have any idea? Let's see here. Yes, you are correct. D can be calculated using Pythagoras. So we will find out the difference between the value of x here and the value of y here. Subtract and then square it. Using Pythagoras, you can calculate d squared. Is it correct? Yeah? Then, we will square this out. Don't worry, this is long but we can make it simple later. Yeah? So this is square, so you have cos square alpha minus, become minus 2 cos alpha cos beta for the minus 2ab part. And we have minus cos beta in square form, become cos square beta. The same with this part, you can check that the expansion is already correct, isn't it? So, now for the step 3, we will calculate the square part, cos square alpha and sine square alpha together. And then I put out minus 2, both terms here. So we have minus 2 cos alpha cos beta plus sine alpha sine beta. And then for the cos square beta and sine square beta, we also put it together. Next, you remember what is cos square plus sine square in 10th grade? You have the formula of identity, right? So this is become 1, add it with 1, so we have 2, yeah? And then we have minus 2 cos alpha cos beta and sin alpha sin beta. So this is our first equation for d squared. Let's keep it first and continue to the next slide. After finding distance between these 2 points, cos alpha sin alpha and cos beta sin beta, now we will try to find it in another way so we can compare it later. We take out this triangle and rotate it beta degree to the x-axis. So now the angle become alpha minus beta because you subtract beta degree and rotate it to the x-axis. Here, the radius is still 1 and the d also not changing. So now, this point become cos alpha minus beta, comma sin alpha minus beta because the angle is alpha minus beta, right? And this point, because this is the x-intercept, it's become 1, 0. So now we will try to calculate this distance again using these 2 points. With the same way, using Pythagoras, we will subtract the difference of x and also the difference of y. So we have cos alpha minus beta minus 1 square plus sin alpha minus beta minus 0 square. Then, we expand cos square alpha minus beta minus 2 cos alpha minus beta plus 1 plus sin square alpha minus beta. Next, we collect the cos square and sin square together to get 1 and add with this, so we have 2 minus 2 cos alpha minus beta as the second equation. So joining those 2 equations together, this is the first equation and this is the second equation. We will match the terms together. We have 2 and 2 here, and we have also minus 2 and minus 2 here. So we can conclude that cos alpha minus beta is equal to these all terms. Like this. So this is our first formula. Cos alpha minus beta equal cos alpha cos beta plus sin alpha sin beta. So later we can use this formula to calculate cos, for example, 60 minus 45. And you substitute alpha, for example, with 60 and beta, for example, with 45, and you can calculate cos 15. Let's see the example later. Wow, what is that? Do you know what is that? This is our diamond point. So you got your first diamond point and wait until the end of the video and count how many diamond points you can get in this video. The next one, we will derive the formula for cos alpha plus beta. If at the previous derivation we derive cos alpha minus beta, now it is for cos alpha plus beta. And for example, later we can use it for cos 75. See the first step. From what we got on cos alpha minus beta, cos alpha cos beta plus sin alpha sin beta, you can replace beta with minus beta. So what we have now, since it is become minus beta, what we have in here, then we can substitute all beta with minus beta. So the first beta here become minus beta and the second beta here become minus beta. Using the relation between angle in fourth quadrant for negative angle, at the first terms here, we have cos alpha plus beta. And cos alpha cos minus beta will not be changed. It will be still cos alpha cos beta. But for sin alpha sin minus beta, since it is sin in fourth quadrant, which is negative, then this term become minus sin beta and you get the minus sign here. So that's the result for cos alpha plus beta. you can see this is the changes. At the first, it is plus. Now it become minus. So you can see when alpha subtracted by beta like this side is plus. But if alpha is added by beta, this side will be negative. You can see the difference, right? Okay, next, this is what we will count using cos alpha plus beta. We will calculate the exact value of cos 75. So using our spatial angle value, we can calculate it like this.